Here is the bottom of my vacuum cup. This was made from a 1/2-inch piece of plywood. Notice in the middle you can see the bottom of the flush-mounted 1.5" Schedule 40 PVC nipple glued and sealed with hot melt glue. The vacuum hose gets attached to the other side, which was the top, with an adapter that came with the shop vac. Also notice the door seal around the edge. The seal shown is the first one I used, but was too porous to seal well. I glued some strings to the bottom to make sure the plywood did not flex and close off my vacuum air path in case of leakage. The next shot will show the seal that worked really well. This seal was also 4-door weather stripping, but it was closed cell rubber which did not leak and had ribs which may or may not have helped. The back side of the rubber has a glue strip revealed when you take off the paper tape. I wrapped the rubber continuously around the lifter, made my joint in the middle of one side with a diagonal cut to avoid a leak directly through the seal. The first one lifted my 100-pound 18 by 27-inch slabs and the 18 by 18-inch slabs. The smaller device lifted the 9 by 18 slabs. The smaller one also lifted the 100-pound slabs, but I kind of didn't trust it. Both of these were made from repurposed lumber. My large lifter was 14.5 by 14.5, which equals 210 square inches. Those dimensions were inside of the rubber seal. Multiply that 210 square inches by my 2 psi vacuum, results in a theoretical 420-pound lift potential. If I gave it at least a 2-to-1 safety factor for all kinds of eventualities, it easily lifted my 100-pound slab. Here are some drawings. This is the cutaway view. Notice the nipple in the middle. Seal that with hot melt glue. Seal at the bottom, and the stack of 2x4s for handles. That shows a 3-dimensional view from the top. This next one will show the 3-dimensional view from the bottom. Notice the strings, the layout that I've made. It doesn't matter what the layout is, but that looked nice on the drawing. You will be sucking water up tubing and measuring the height your vacuum is able to lift the water. Every 2 feet your vacuum can lift equates to 1 pound per square inch of vacuum. Put a bottle or a bucket on the floor and fill it with water. Have at least 8 feet of tubing to work with. Put one end of the tubing in the water and form a loop overhead at least 7 feet high. Put a measuring stick behind the tubing to measure how high your vacuum will lift the water. Turn your vacuum on, put the tube into the hose, and gradually seal the end of the vacuum hose with your hand and fingers. Make a note of how high the water column rises. If you're using a vacuum other than a shop vac suited for vacuuming water, be careful not to allow the water to go over the top, or it will get into the vacuum cleaner and possibly damage it. The best thing to do is to gradually pinch your fingers around the tubing and make your seal. Otherwise, you're liable to have the water go over the top and into your vacuum cleaner. If you have your measuring device on the floor, subtract the difference from the floor to the top of your water supply before recording your measurement. Make your measurement the nearest half foot. The PSI of your vacuum will be 1/2 the number of feet the water column has risen. If you multiply the PSI times the area of your suction cup, you will determine the theoretical ability of your lift. For example, take 2 psi times 100 square inches. It will equal 200 pounds of lift. Make a few test lifts on a sturdy floor surface to get a feel for the lift ability. Make sure that you use a sturdy surface without any tile, or you may damage the tile when you try to make your lift.